Okay, in this video I'm going to talk about how you can switch the formula for circular motion into the terms of frequency or period. If you imagine an object moving in a circle, you can imagine how we can view this as a repeated motion. The object goes around and around and around, and so one repeating unit would be one time around the circle for the object. When we have repeated motions in physics, we often like to state them in terms of their frequency or their period. Recall that frequency refers to the number of times that repeated motion would occur in a second, or the number of cycles per second, or the number of cycles per time, and that the period refers to the amount of time for one cycle. So to do that, what I want here in my typical circular motion acceleration formula, I have speed. So I want to find a way to put speed in terms of frequency or period. If I get one, it's pretty easy to switch to the other. Recall then, you can see the reciprocal relationship here. And for period, by the way, I'm typically going to use the capital T as the symbol. I can see that my frequency is equal to 1 over my period, or my period is equal to 1 over my frequency. You can see the reciprocal relationship there. So if I can get it in terms of 1, then I can change it to the other fairly easily. Now let's recognize that to find my speed, I'm going to use one cycle or one time all the way around the circle. In that situation then, my speed is going to be my distance over my time. The distance to travel around the circle one time will be 2 pi r. And by definition, the amount of time that it takes to go through one cycle will be my period. Sorry, that should be a capital T, period. So I can take this and I can substitute it into my acceleration formula. And then I can simplify. That squared applies to everything, so 2 squared is 4, pi squared, r squared, over period squared, and that's all over radius. Now I want to clear this radius in the bottom, so I can imagine inverting and multiplying. And so it will cancel with one of the radiuses on the top. So if I have an object in uniform circular motion, and I want to change from this formula to a formula in terms of period, using one cycle, I can show that the acceleration is equal to 4 pi squared r over the period squared. Now, using the reciprocal relationship for frequency, I can then just adjust this equation for frequency. So I can also say that the acceleration is equal to 4 pi squared r, and since the period was on the bottom and it's reciprocal, the frequency will appear on the top. So that's how I can adjust my circular motion equation, which was in terms of velocity, so that it is in terms of period or frequency.